Hello friends, let's have a look at problem 2405, optimal partition of string. So in this video, we're going to share a solution based on set, abstract data type, and check. So basically, we use set as a helper and do the counting during the linear traversal of the string. First, I'll read through the statement of the problem, and then we do a simple analysis, and finally we share the code. First, let's look at the statement of the problem. Given a string S, partition the string into one or more substrings such that the characters in each substring are unique. That is, no letter appears in a single substring more than once. So that's the main requirement for this problem. So we are required to return the minimum number of substrings in such a partition. So here is a note. So note that each character should belong to exactly one substring in a partition. So actually this is sort of redundancy, because if we think of the meaning of partition, it should be the case. So let's look at the two examples here. So in example 1, so the output is 4. So we have AB, AC, and AB, and A. This is the one possibility. So here, actually, the explanation demonstrates that the possible partitions are actually not unique, but the number of substrings are unique, so optimal ones. So in example 2, so the S consists of a single character and repeated 6 times. So the output is 6 in this case. So each substring contains a single character S. So that's the second example. So the constraints or additional assumptions for this problem are the following. First, the length of S is bounded below by 1. In other words, S is not empty. And the length is bounded above by 10 to the power 5. So this defines the problem size. And secondly, S consists of only lowercase English letters. So that's basically confines also the size. We'll see. So with that said, let's look at the method we are going to share. So here the method is the standard set and check. So the procedure is as follows. First, we are going to do linear traversal of S with a set as a checker. So when we see a character which is in the set, so which means that we need to start a new substring. So we are going to increment the counting by 1 and reset the set to be the current character. So let's see, S equals a single element set, which is the current character. So another case is that when we see a character which is not in the set, so we can add the current character to a previous string. So we add the character to the set. So this is actually straightforward, but here's a caution. So we need to pay attention to the last character or last grouping. So when we do the case. So here is a walkthrough. So this is example 1. So if we do the partition using the above procedure, so this is the corresponding partition. So actually we are sort of using a greedy method. So we can greedily add as many characters as possible to a substring. So this is one example. So another example we cooked up is A, B, C, D, E, and A. So we can have A, B, C, D, E, so and A. So this is the one possible partition. But we can also have A, B, and C, D, E, A. So this is another possible way of doing the partition. But the groups or the number of substrings are unique. That is 2. So with that said, so we are ready to share the code. For this purpose, first let's check the length of this string. Let's call it M. And then we're going to initialize a variable called result, whose final state is what we want to return. And then we start from the first character, indexed with 0. So we're going to introduce a set. Let's call this window. And then we're going to do the linear traversal. So while I less than M. Then we're going to check the current character SI. So if SI is in the window, then what we're going to do is that we're going to add the 1 to the current result. The reason is that we're using SI to start a new substring. So in this case, we also need to set the window to be SI. So this is the one case. Another case is that SI is not in window. So in this case, we're going to add this character in the previous string. Then we corresponding to add the SI to the check set. So this is another case. So one thing to be noticed that is the case when I equals n-1. So in this case, so we are going to add the result by 1 or increment the result by 1. So counting the last group. So this is actually a subtle detail. So in either way, so we're going to increment this I by 1. So with that said, so we are ready actually to return the result. So with that said, let's first do a special case check. Yeah, it passes the first example. So now let's look at the second example. So this actually demonstrates a case. So if we have a single character, it repeats sometimes, then so we should have 6. So as it is. So now let's do a generic case check. Yeah, it passes all the generic cases. So I guess with that said, that's about it for a solution to this problem. The format of solution we present is one of the possible ways to solve the problem. You can do some variants based on the current thought. So with that said, I guess that's all about this video. Thank you very much.